Hey guys, how you going? Today we've got an integration question where it's asking us to show that the definite integral of this rational function is equal to 16 root 2 minus 12. Now I'm not going to dilly-daddle around with showing you guys like the actual mechanics of the integration. I am going to show you a few of the methods that I would use to make this question easier in an exam, but I'm not going to specifically go through blow by blow of what I'm doing. So if if you don't understand how integration actually works, then you probably want to, check another video out before you go and watch this one. But if you sort of got a good grounding, let's take this one for a whirl. All right, so what we're going to do is the first thing that I see with this problem is I've got no idea how that you would integrate this by just approaching it like that. So what you can do though is we can use a few of the different integral laws to make this a problem that's solvable for anybody. So the first law we're going to use is if we've got a function, or y, that's basically defined as f of x plus g of x, what we can do is if we're going to try and integrate y with respect to x, we can actually write this as, rather than the integral of all of this, we can write this as the integral of f of x dx plus the integral of g of x dx. So this is quite important when we're approaching more complex functions like this, when we're trying to integrate them. So let's go about and see how we can apply this to this. So what we're going to do is we're going to split this fraction up into 6x over root x and 4 over root x. So basically what this is going to do is we're going to say the first thing, this is equal to the definite integral from 1 to 2 of 6x on square root x dx plus the definite integral from 1 to 2 of 4 divided by square root x dx. Now, what we can do here is we're going to simplify this a little bit more. We know that the square, from hopefully pre-calc, your indices sort of laws, you know the square root of x is equivalent to x to the power of 1/2. So what we're going to do is with that knowledge, we're going to put this in. We're going to go, this is equal to the definite integral 1 to 2 of 6x over x to the power of 1/2 dx plus 1 to 2 4 divided by x to the power of 1 over 2 dx. Cool. So now we've got that, we can just finally simplify it and then we can do our integral. So this is now going to equal the definite integral of 1 to 2 of 6x to the power of 1/2, because that's just x to the 1 minus x to the 1 divided by x to the half is x to the 1 take a half. So there, and then we're adding to that 1 to 2. We're going to just take the x up to the top, and what we have is we've got another index law which says a to the n, 1 over a to the n is equal to a to the negative n. So using that law, we're going to say this is equal to 4x to the negative 1 over 2 dx. Cool. So now after we've done that, we can now go about actually performing the integrals. So what we're going to do is we're going to raise the power by 1. So this is now going to be equal to, we're going to evaluate this, it's going to be x to the power of 3 over 2, and then we're going to multiply this by 2 over 3. So 6 times 2 is 12, divided by 3 is 4. And we're going to evaluate that between 1 and 2, and we're going to add that to, add 1 to this, we've got x to the power of 1/2. So this is going to be 8x to the power of 1/2. evaluated between 1 and 2. Cool. So from here, we just evaluate these two integrals. So if you get to here unscathed, it's just working out, doing the algebra to get to the end and not making a silly mistake. So what we're going to do is this is going to be 4 times 2 to the power of 3 over 2. Subtract 4 times 1 to the power of 3 over 2. And we're adding that to this integral, which is 8 times 2 to the half minus 8 times 1 to the half. Cool. So what we'll do is we will take this up here. Let me just change the color. From memory, this question was worth about, I think, 4 or 5 marks. So you've got a little bit of time. You've got to get through it fast, but they make allowance for the actual solving this by hand because it was in a non-calculator part of an exam. So let's evaluate this. This is going to be 2 to the power of 3 over 2. 2 to the power of 3 over 2 is equal to 2 to the power of 1 times 2 to the power of a half. So that's going to be equal to 8 times, it's going to be equal to 4 times 2 square root 2, and minus 1 to the power of anything is still 1, so it's going to be minus 4. And then this is minus, here, plus 2 to the half is just square root 2, minus 8. Cool. So let's do that multiplication there, and we're left with 4 times 2 is 8, square root 2, minus 4, plus 8 square root 2 minus 8. Cool. So now we can join our like terms up. So 8 root 2 plus 8 root 2 is equal to, would you believe, 16 square root 2. Negative 4 minus 8 is negative 12. And what we do is then we look up, we check that we're good to go, and yeah, that is the problem solved. So basically these problems, the crux of this problem was, first of all, identifying that you could split this fraction into 2 and then solve each of them individually, which makes the the integral a lot easier to compute. Once you've computed the integral, evaluating it and then getting to the final answer is a rigmarole, but it's not too complicated. You just have to make sure you're on point with your algebra. But once you've got through all that nonsense, you'll come out with an answer, you'll get 4 marks in the bank, and you can go on to the next question with your head held high. So, hope this video helped. Give it a like if it did. Do us a favour, subscribe to my channel. I put out videos basically every day. If you need to ask me a question, you can. I have no problem with that. But until next time, catch you on the flip-flop.